Okay, so let's get started. We're going to be taking a look at working with our Hall effect sensor setup within our Link G5 and G4X programming. And this is going to be specifically related to working with our cam and crank triggers. These are what we essentially send a signal from the sensor, the trigger sensor, into the link so we understand the engine's position that's used to calculate fuel and spark timing. These are essentially the most critical sensors that we have to make sure are configured correctly and that the link is reading correctly in order for the engine to run properly, or else fuel and spark timing calculations will not happen at the correct time. Engine won't run in a lot of cases, or it'll run erratically or very poorly. We absolutely need to make sure that these details are covered properly. This training module is going to focus on a Hall effect style sensor configuration setup. The next training module, we're going to be working with the reluctor style sensors, so the difference between the two sensors, and we're going to be covering those basic details at the beginning of the training module, and then going in and learning how to program a Hall effect sensor properly, and then also talking about the various different trigger patterns and using a trigger scope to determine some of the other details for working in a Hall effect sensor. Okay, let's jump in here and talk about some of the basic fundamentals that we need to know. First things first, we're going to find that we have two different type of sensors we may find fitted to our engine for a cam or a crank sensor, and that's going to be a reluctor style sensor or a Hall effect sensor. Now, coming up on screen, I have a picture here that's going to give you a little bit better representation of what they actually mean. And a reluctor sensor, you can look at the sensor and there's two wires coming out of the sensor. That's one visual way we know if we have a reluctor sensor or a Hall effect. Take a look down below at the other example. The Hall effect sensor is going to have three wires. There's going to be a power, a ground, and a signal output. So visually, you can look at your camera crank sensor, 2-wire reluctor, 3-wire Hall effect. Obviously, this tutorial we're going to be covering the Hall effect sensor, but getting back to the actual other sensor differences, what we'll find is every time a tooth passes over or passes across a reluctor, it's going to produce a sinusoidal wave, and we can see that represented there. Now that's going to have a certain amount of voltage output. As engine speed increases, the amplitude of the voltage of that sine wave will grow. We'll find, looking at the Hall effect, that's going to produce a square wave signal, a 0 to 5 volt pulse typically. And in this case, the faster the engine's spinning, the more times it's going to have the tooth passing across the sensor, the more pulses we'll have in a given amount of time. That's how the ECU is going to detect the engine speed. So reluctor, we'll look at that sinusoidal wave growing, so the amplitude growth gives the ECU the ability to detect engine speed. And then the Hall effect sensor, that's going to produce more pulses in a given amount of time. That'll tell the ECU that the engine's spinning faster. So that's going to be how it counts the cam and crank within the respective type of sensor. In this case, we're working with a Hall effect sensor in the tutorial here. So we're going to assume your engine's fitted with Hall effect sensors. That's pretty standard for most modern engines, although a lot of OEM manufacturers still stick with a reluctor style sensor. The benefit to a reluctor sensor is that they're very simplistic and they rarely go bad. So 2-wire sensor, it generates its own magnetic wave field, produces a voltage output, very reliable. They use these a lot on ABS sensors for ABS control, traction control. The Hall effect is still a reliable sensor, and by today's standards, they produce very reliable sensors. So a lot of manufacturers are using the Hall effect sensor. These produce a much cleaner waveform. That pulse is much easier for the ECU to count each tooth compared to that sinusoidal wave that's outputted from a reluctor sensor. So the benefit of reluctor, a little bit more reliable. Benefit of a Hall effect, cleaner signal. All right, let's jump in here and take a look at the next step of finding where we can actually program our cam and crank settings for a Hall effect sensor. Jumping from our fuel page right here, we're going to move across and we're going to go to our cam crank page. In here, we have our trigger setup, trigger 1 and trigger 2. These details have to be programmed properly in order for the link to understand, number one, what type of sensor we're dealing with, and then number two, what pattern we're dealing with. So how many pulses are going to happen within an engine cycle as it's going and spinning through the engine cycle. It has to be correct It has to count everything correctly. If it doesn't, it's not going to know where the engine's position's at. It won't be able to time things like spark timing or fuel injection, and we'll find the engine won't run correctly. So we need to make sure that this is set up properly. First thing we're going to find here under the trigger setup, we have our trigger mode. We can find we have a lot of options in here. Multi-tooth missing, and then as we scroll through here, we see a lot of different engines and manufacturers listed here. These are going to be specific to those vehicles and to the engines that are fitted in those vehicles. So these patterns are unique, meaning they may have missing teeth on the cam and crank or extra pulses on the cam and crank, and they can't be properly represented through the multi-tooth or multi-tooth missing options. These are more of a universal option. So for example, if we have an engine and we're fitting it with a cam and crank setup, so we're putting aftermarket setup on there, we're not using the OEM cam and crank, we would generally have something with a multi-tooth or multi-tooth missing option. However, if we're using the OEM sensors, the OEM pulse plates, so it's using all of the OEM pattern and how the engine was designed from the manufacturer, we'll be using one of these other various options. You can see there are quite a few engines here supported, so chances are you'll find that in the list. Let me go through here and let's go and just select multi-tooth missing option, because the cam and crank trigger that I am working with for my engine here is a 36 missing 2 teeth, and then I have +1 on the home, meaning I have just a single pulse in the home, so I'll have to configure all this. So we definitely want to know the pattern we're working with. Now, if you don't know the pattern, you don't necessarily have to go in and select the correct one yet. You could use the trigger scope to determine that, but we need to absolutely make sure we know what sensor type we're working with, because in our trigger 1 and trigger 2 settings, we need to make sure that we're setting this either to a Hall effect or a reluctor. And again, we know the difference because a reluctor will have 2 wires, a Hall effect will have 3 wires. So visually we can check it and we know which one to select. We have to make sure we're selecting under the trigger options here the type of sensor we're dealing with, because if you're using the trigger scope, it'll count and look at the actual output from the sensor differently depending on what we choose here. Because when we're dealing with a reluctor, it's an AC sinusoidal wave. When we're dealing with an optical Hall effect, that's a DC square wave signal. So the way the trigger scope's going to process things will be incorrect if we have the incorrect sensor selection here. All right, I'm going to choose multi-tooth missing because I do know my pattern I'm working with. Again, if you don't know your pattern, just select multi-tooth or multi-tooth missing, doesn't really matter, but I know my pattern, so I'm going to click OK here.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.